Today class we will discuss problems on end arrays, that is problem on broadside array and problem on identifier array. So, see here, this is the problem on broadside array. This is the problem on broadside array. So, what is the given data? So, totally how many number of elements are there in this problem? So let us first read the problem. A broadside array of identical antennas consisting of 8 isotropic radiators separated by a distance lambda by 2. Find the radiation field in a plane containing the line of array showing directions of maximas and null. Okay. So here given the number of elements. Given the number of elements. N is equal to 8. The separation distance is T is equal to lambda by 2. Separation distance is T is equal to lambda by 2. They have calculated in which direction it will radiate. Okay, so first one, let us take the maximum direction. Maximum direction means the condition for the maximum direction is psi should be equal to 0. What is the value of psi? Psi value is beta d cos theta plus alpha is equal to 0. So in broadside array, alpha is equal to 0. Therefore, beta d cos phi max is equal to 0. Okay. So from this, therefore, cos phi max is equal to 0. Applying cos inverse. Okay, so maximum direction. For what value of cos I will get 0 degrees? It is for 90 degrees and 270 degrees. Okay. So in a broadside array, my maximum radiation will occur at 90 degrees and 270 degrees. Okay, so this is the first one. This is for maximum radiation direction. Maximum radiation direction. Maximum radiation direction. So in a broadside array, my maximum radiation occurs at 90 degrees and 270 degrees. Okay. Now let us come to the second one, that is magnitude of major. Magnitude of major lobe. So what is the formula for the magnitude of major lobe in a broadside array? Et by E naught is equal to n. Here what is the value of n? N is equal to 8. Since 8, they have given 8 elements are there. Okay, so this is the second. Now let us calculate the third one. Okay, what is the third one? Third one is nulls. Okay. So what is the formula for the nulls in a broadside array? By minimum direction is equal to cos inverse of plus or minus m lambda by n t, where the value of m is equal to 1, 2, 3, 4. Okay. So now let's calculate first null, second null, third null, fourth null, like that. Okay. So let us consider phi minimum 1. Phi minimum 1 means that is for m is equal to 1. For m is equal to, so that is phi minimum 1 is equal to cos inverse of plus or minus the value of m is equal to 1 lambda by what is the value of n? The value of n is 8. What is the value of d? The value of d is lambda by 2. Separation d is separation by distance. So lambda will get cancelled to 1s to 4s. Okay, so it is equal to cos inverse of plus or minus 1 by 2. So what is the value of cos inverse of plus or minus phi minimum 1? So the value is I will calculate in the calculator. So calculator cos inverse of plus or minus 1 by 4. Its value is 75.52 degrees. For plus it is 75.5 degrees. And for minus it is 104.47 degrees. So this is the value of first null. This is the value of first null. Okay. So similarly, you want to calculate the position of second null and calculate the position of third null. Now let us calculate phi minimum 2. Phi minimum 2 means you want to substitute m is equal to 2. Therefore, pi minimum 2 is equal to cos inverse of, what is the original formula? M lambda by nd, that is cos inverse of the value of m is 2 lambda by n is 8 into lambda by 2. Okay, so lambda gets cancelled, 2 ones, 2 fours. Okay, 2 ones, 2 twos. So that is cos inverse of plus or minus cos inverse of plus or minus 1 by 2. Okay. So pi minimum 2 is equal to, what is the value of cos inverse of plus or minus 1 by 2? It is 60 degrees and 120. So next, let us calculate pi minimum 3. Pi minimum 3 means we want to substitute in the equation m is equal to 3. So pi minimum 3 is equal to cos inverse of plus or minus 3 lambda by the value of n is 8 and the value of d is lambda by 2. So it is lambda by 2, lambda get cancel, that is equal to cos inverse of plus or minus 6 by 8 or cos inverse of this plus or minus 3 by 4. So what is the value of pi minimum 3? Pi minimum 3 is equal to plus or minus t is 1.4 degrees and 138.6 degrees. Okay. So totally I've got 3 pi minimums. Okay. So this is how you can calculate for pi minimum 4 like that also. Calculate for pi minimum 3, 4 like that. Okay. Now let us come to the next one. Fourth point is side loops. Next one is side loops. Okay. So what is the expression to calculate for side loops? In a broadside array, pi side loops is equal to the expression for calculating the side loops is pi side loops is equal to cos inverse of plus or minus lambda into 2m plus 1 by 2nd. Okay, where m is equal to 1, 2, 3, so on. Okay. So let us calculate the first side loop. Let us calculate the first side loop, SL1. So SL1 means you want to substitute m is equal to, therefore, pi SL1 is equal to cos inverse of plus or minus lambda into 2m, m value is 1. So 2 plus 1, 3 by 2 and 2 into the value of n is 8 and the value of t is lambda by 2. So 2 will get cancelled. Okay. So lambda will get cancelled. So pi SL1 is equal to cos inverse of plus or minus 3 by 8. It is the value is plus or minus 3 by 8. So what is the value of cos inverse plus or minus 3 by 8? Its value is 67.97 degrees, and for plus it is that one and for minus it is 112 degrees. Okay. So similarly, let us calculate for SL2. SL2 means you want to take m is equal to 2. So SL2 is equal to cos inverse of plus or minus lambda into the value of m is equal to 2. 2 into 2 to 4. 4 plus 1 is 5. 5 by 2 into, what is the value of n? 8 into lambda by 2. The 2 will get cancelled. Okay, lambda will get cancelled. So the value is cos inverse of plus or minus 5 by 8. What is the value of cos inverse of plus or minus 5 by 8? Its value is 51.31 degrees and 128.68 degrees. Okay. Similarly, calculate pi SL3. Side loop diagram. That is for Pm is equal to 3. Therefore, pi SL3 is equal to cos inverse of plus or minus. Okay. So what is the formula? Lambda into 2m. Here 2m is 2 into 3, 6 plus 1, 7 by 2 into the value of n is 8 into d is lambda by 2. Okay. So 2 will get cancelled, lambda will get cancelled. that is equal to cos inverse of plus or minus 7 by 8. What is the value of cos inverse of plus or minus 7 by 8? This value is for positive it is 28.595 degrees and for negative it is 151.04. Okay. Now write all the values here once here. Whatever the things you have calculated right here. So pi max or theta max we are getting at 90 degrees and 270 degrees and phi minimum 1. Phi minimum 1. We are getting phi minimum 1 at 75.52 degrees and 104.47 degrees. Phi minimum 2. Phi minimum 2. We are getting at 60 degrees and 120 degrees. Phi minimum 3. We are getting at 41.4 degrees and 138.6 degrees. Okay, so similarly, pi side loop 1, you are getting at 67.97 degrees and 112.0 degrees. And pi SL2, you are getting at 51.31 degrees and 128.68 degrees. Pi SL3, we have got between 28.95 and 151.04 degrees. Okay, so you can verify your answers. Now, these are all the relations regarding broadside. These are all the things regarding broadside array. Now, we want to draw the diagram and insert all these things. Okay. So, the diagram is the very, very important for draw the diagram carefully. Okay, so this is my diagram. Okay. So this is theta alpha is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. Okay. So first, since the first draw the nulls. Okay. So the first null is at 75 degrees and 104 degrees. Okay. The first null is at 75 degrees. So 75 degrees means this is 40 degrees. Okay. So 75 degrees means you get like this. 75 degrees. Okay, I will draw with the dotted line. So I'm drawing that side loop left with dotted lines. Draw with care, utmost care. So this is 75 degrees. And similarly, this is S minimum 1. This is also pi minimum 1. Okay, next pi minimum 2 is 60 degrees and 120 degrees. So this is pi minimum 2 and this is pi minimum 2. Okay. Next, pi minimum 3 is 41.4. This is pi minimum 3. And another one is 138. So this is pi minimum 3. Its degrees are 138.6 and here it is 41.4. Here the degrees is 60 degrees. Here it is 120 degrees. Here it is 104 Here it is 75. Okay. Now, you first to draw the maximum direction. Maximum direction you are getting at 90 degrees and 270 degrees. 90 degrees and 270 degrees. Okay. 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 Let us draw the maximum direction. This is my maximum radiation peak. That is in 90 degrees and 270 direction. 90 degrees and 270 direction maximum radiation. Okay. Now, what is the side loop level? First side loop level. So this is major first side loop level. You want to notice that whether you have got the correct answer or not. How will you check whether you have got the correct answer or not? Okay, so you can check the correct answer for that. The first side loop level lies in between first null and second. Okay, so for example, so first null is 75 degrees and second null is 60 degrees. Your answer was lies between first, always the first side loop lies between first null and second. Okay, so 67.97 lies in between 60 and 75. Similarly, second side loop level lies in between second null and third null. Okay, so your second null is 60 degrees and your third null is 41.41.4. What is your side loop level? It is 51.3. Okay, 51.3. Now I am going to draw the side loops. I'm going to draw the side loop. So now the first side loop. So I'm drawing the first side loop. This is my first side loop. And similarly, this is my first side loop, which is in between first null and second null. Okay, so this is nothing but my first side loop. First side loop one. This is my first side loop. Okay. So similarly, what is the side loop level? 51.3. It should be in between compulsorily second minimum and third minimum. Okay, so this is the second side loop. This is side loop level 2. This is side loop level 2. Okay, so third side loop. Third side loop level will be in between third minimum and fourth minimum. So this is my third side loop. This is my third side loop. So this is SL3. This is SL3. Okay. So while you are drawing the side loops also, you want to reduce the amplitude. For example, so what is the amplitude of the major loop? It is 8. So as you are coming to the first, this is major loop. Okay. As you are coming to the second side loop, the height or the radiation of the second side loop would be very, very less when compared to the major loop. And similarly, the second side loop radiation should be less when compared to the first side loop. And the third radiation of side loop 3 should be less when compared to the radiation of second side. Okay, this is how you want to draw. So this is the radiation pattern of an broadside array. Broadside array with how many elements? With 8 elements, and the spacing is And the spacing, what is the spacing? Spacing B is equal to lambda by 2. And the spacing B is equal to lambda by 2. So this is how we will do the problem, okay, on broadside array. Similarly, let us do one problem on N-fire array. So do one problem on N-fire array. Okay, so let I will take the problem. So the problem is, question of the problem is, draw the radiation pattern of N-fire array of 8 elements with the half wavelength and the uniform spacing and the uniform amplitude distribution and the uniform amplitude distribution. Find side lobes, nulls, direction. The same thing here. The same thing. Okay. So solution. Okay. So here, what is the given data? Here, the value of n is equal to 8. The value of n is equal to 8. And the spacing is, they have given that it is half wavelength. Half wavelength, that is t is equal to lambda by 2. Now here, which type of array it is? N-fire array. Now, the same thing, whatever you have followed for broadside array, the same thing you will go for N-fire array. You go for N-fire array. Okay, so let us take first one for major. Okay, so for major lobe, what is the condition? The psi should be equal to 0. What is the value of psi? Psi broadside array, the value of psi is equal to beta d cos phi max minus 1 is equal to 0. Therefore, cos phi max is equal to 1. Okay, so for what value you will get for phi max? The maximum radiation is 0 degrees. So the maximum radiation you are getting for 0 degrees. In a N-fire array, the maximum radiation you are getting for 0 degrees. Okay. Now let us go to the second point. Now let us go to the second one. What is the second point? That is magnitude of major. Magnitude of major lobe. So what is the magnitude of major lobe? We know that Et by E naught is equal to n. Here, what is the value of n? N is equal to 80. Okay, next, third one. Now we go for nulls. Next one is nulls. Okay. So phi minimum. What is the formula for the phi minimum? Phi minimum is equal to cos inverse of 1 minus m lambda by 3. Okay. So here no plus or minus. Okay, here only we are having minus. Okay. So where m is equal to 1, 2, 3, 4, so on. Where m is equal to 1, 2, 3, 4, so on. Okay, let us calculate phi minimum 1. That is for m is equal to 1. Okay, so simply substitute here. Phi minimum 1 is equal to cos inverse of 1 minus, here the value of m is 1. Okay. Lambda by, what is the value of n? N is 8 into what is the value of d is lambda by 2. Lambda will get cancelled 2 ones to 4. So it is cos inverse of 1 minus 1 by 4. So what is the value of cos inverse of 1 minus 1 by 4? Phi minimum 1 is equal to cos inverse of 3 by 4. The value is 41.40 degrees. The value is 41.40 degrees. Okay, so I can take this as 41.40 degrees. Okay, next. Similarly for phi minimum 2. Phi minimum 2 means what is the value of m? M is equal to 2. So simply substitute here. phi minimum 2 is equal to cos inverse of 1 minus, here what is the value of m? M is equal to 2 lambda by, what is the value of n? N into lambda into, what is the value of t? Lambda by 2. Okay. So 2 ones, 2 fours, 2 ones, 2 twos, lambda will get cancel. It is cos inverse of 1 by 2. So what is the value of phi minimum 2? Phi minimum 2 is equal to plus or minus 60 degrees. No 60 degrees. Okay. Now let us come to the phi minimum. Phi minimum 3, that is m is equal to 3. Okay. So what is the formula? Cos inverse of 1 minus 3 lambda by n. N is 8 into t is lambda by 2. The lambda get cancelled, 2 ones, 2 fours. It is equal to cos inverse of 1 minus 3 by 4. That is equal to cos inverse of 1 by 4. That is equal to plus or minus 75.52 degrees. 75.52. Similarly, calculate phi minimum 4. Okay. So phi minimum 4. Okay. So phi minimum 4. Here you can write it as m is equal to 4. That is cos inverse of 1 minus 4 lambda by 8 into lambda by 2. 4 ones, 4 twos, 2 to get cancelled. So that is cos inverse 0, that is equal to 90 degrees. Okay. Next, phi minimum 5. Phi minimum 5. That is equal to m is equal to 5. That is equal to cos inverse of 1 minus 5 lambda by 8 into lambda by 2. That is cos inverse 1 by 4. That is plus or minus 0.47. Okay. So the values for minimum. Okay. So null direction. Okay. Now similarly, let us calculate side to direction for end fire. So what is the formula for the side to direction? It is equal to plus or minus cos inverse of 1 minus lambda into 2m plus 1 by 2m. Okay. So let us take phi SL1 side lobe 1. Where here, what is the value of m here? Here m is equal to 1, 2, 3, 4. Okay. So phi side loop 1, that is for m is equal to 1. Okay. Now substitute here phi side loop 1 is equal to plus or minus cos inverse of 1 minus lambda into the value of m is equal to 1. So 2 plus 1, 3 by 2 into 8 into lambda by 2. Lambda will get cancelled. So it is plus or minus cos inverse of 1 minus 3 by the value of 1 minus 3 by 8. If you substitute here, phi side loop level 1 is equal to plus or minus 1.31 degrees. Okay, so similarly, phi SL2, that is for m is equal to, simply substitute here, plus or minus cos inverse of 1 minus lambda into 2 into 2, 4, 4 plus 1, it is 5. 5 by 2 into 8 into lambda by 2. Lambda will get cancelled. That is equal to plus or minus cos inverse of 1 minus 5 by 8. So therefore, SL2 is equal to plus or minus 67.97. 67.97. Okay. Now let us go for the third one. Phi SL3. That is for m is equal to 3. That is equal to, what is the formula? Plus or minus cos inverse of 1 minus lambda into, here m is equal to 3. 2 into 3, 6 plus 1, 7 by 2 into d is 8 into lambda by 2. Once to cancel. And lambda will get cancelled. So it's equal to plus or minus cos inverse of 1 minus 7 by 8. So 1 minus 7 by 8 is equal to plus or minus 82.82 degrees. So similarly, pi SL4, that is for m is equal to 4, that is equal to plus or minus cos inverse of 1 minus lambda into 2 into 4, 8 plus 1, 9 by 2 into 8 into lambda by 2. Lambda get cancelled. 2 will get cancelled. That is equal to plus or minus cos inverse of 1 minus 9 by 8. Okay, so that is equal to plus or minus 97.18. Okay, so these are the things. Okay, now we will write all the values here for an end-fire array in order to draw the diagram. Again, end-fire array in order to draw the diagram for an end-fire array. For an end-fire array, so what is the pi max value? Pi max value is equal to 0 degrees. Pi max value is equal to 0 degrees, and pi minimum value, pi nulls direction, pi nulls direction. By null direction, you are getting it. By null 1, you are getting it plus or minus 1.4 degrees. And phi null 2 or phi minimum 2. Phi minimum 2, you are getting it plus or minus 60 degrees. Phi minimum 3, we are getting it plus or minus 75.52. Phi minimum 4, we are getting it plus or minus 90. Similarly, write down for side to 11, SL1 is equal to plus or minus 51.31 degrees. Pi SL2 is equal to plus or minus 67.97. SL3 is equal to plus or minus 82.82. Pi SL4 is equal to plus or minus 97.18. Pi SL5 is equal to plus or minus 112.02. So you can verify and answer whether you have got here. Okay. Always the first side loop. Always the first side loop should be in between the first null and second. Okay, in between the first null and second null. So the first null is 41.4 and the second null is 60. So you are getting an answer in between first null. Okay, and similarly, second side loop. Second side lobe should be in between second null and third lobe. What is the second null here? 60 degrees, and the third null is 675.52. Your answer is also in between like this. Now let us draw this diagram. Now let us draw this diagram. Draw this diagram very carefully. Okay, so let us consider this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees. Okay, now first draw the maximum radiation. Maximum radiation of the set theta is equal to 0 degrees. So this is my maximum radiation one. So my maximum radiation of the set theta is equal to 0 degrees. This is my maximum radiation. Okay. Now first to identify the nulls direction. First to identify the nulls direction. If you identify the nulls diagram, automatically what is the first null? It is 41.4. So first to indicate the first null direction. It is by minimum 1. Similarly, this is by minimum 1. Next, draw the by minimum 2. It is 60 degrees. This is by minimum 2. This is by minimum 2. Next, identify the by minimum 3. It is 75 degrees. So this is by minimum 3. And this is What is the pi minimum 4? In this direction, this is our pi minimum 4, and this is our pi minimum 4. This is pi minimum 4. Okay. Now let us draw the side loops. Okay. So let us draw the side loops. Now let us draw. Always the first side loop level is 51.31. I have already told that the first side loop always lies in between the first null and second null. So this is my first null, this is my second null. Okay. So see here angles also. First null is at 45.5 and the second null is at 60 degrees. So your first side loop is at 51.5. So I'm buying my first side loop. This is my first side loop. You should draw the amplitude always less than major loop, first side loop. Okay, so this is my first side loop 1. This is my first side loop 1. Okay. Now draw the second side loop. Second side loop is always in between second null and third null. Okay, so this is your second null and this is your third null. So this is my side loop level 2. This is my side loop level 2. Okay. So similarly, side loop level. This is side loop level 3. This is side loop level 3. So this is how we can draw the radiation pattern of an end-fire array, indicating major loops, side loops, nulls direction, nulls direction, nulls direction. Okay. Now, other things also you can calculate. You can calculate the beamwidth between first null for end-fire array. Beamwidth between first null for end-fire array. So what is the formula for the beamwidth between first null for an end-fire array? The formula for beamwidth between first null for an end-fire array is beamwidth between first null for an end-fire array is it is plus or minus 2 into root of 2 lambda by nt. This is in terms of radians. This is in terms of radians. Okay. So let us take here plus or minus 2 into root of 2 into lambda by what is the value of n? 8. What is the value of t? It is lambda by 2. 2 ones, 2 fours, 2 ones, 2 twos. Lambda get cancelled. Okay. So beam between first null is equal to plus or minus 2 into root of 1 by 2. Okay. So what is the value of root of 1 by 2? Beam between first null. So that is beam between first null is equal to plus or minus. Okay, if I bring this 2 inside, okay, it will becomes 4. 4 by 2, that is 2, it is equal to plus or minus root 2. What is the value of root 2? Root 2 value is 1.414 radians. Okay. So beam width between first to null is equal to 1.414. So this is in radians. Okay. So we know that 1 radian is equal to 180.5 degrees. Okay, so that is nothing but 57.185 means the value is 57.3 degrees. Okay. So therefore, beam width between first null is equal to 1.414 into 57.3. 1.414 into 57.3. Its value is equal to 81.2 degrees. Okay, so beam width between first one is equal to 81.2 degrees. Okay. 2 lambda by E and D, N is 8 D. 2 will cancel 1 by 2, 2 ones 2. Sorry, I went wrong. Here lambda got cancelled and 2 ones 2 fours, 2 ones 2 twos. Okay, right. 1 by 2, so it is in 81 point. Similarly, you can half power beam width means nothing but half power beam width means beam width between first nulls by 2. Okay, beam width between first nulls by 2. Okay, so you can subtract this 81.52 by 2. Similarly, you can calculate the directivity also. Similarly, you can calculate the directivity. So how you can calculate the directivity? Directivity of an end fire array is, with the formula it is 4 L by lambda. So what is the formula for the L? Generally, the L is, you consider it as NT when N is large. When N is large. But here the value of N is 8, very less. So here the formula is N minus 1 into D. So 8 minus 1 into lambda by 2. Therefore, directivity is equal to 4 into 8 minus 1 means 7 lambda by 4 into 7 lambda by 2 by lambda. 7 get cancelled, 2 ones, 2 2s. 2 into 7, that is 4. So this is how you can calculate the directivity beam width between first nulls, half power beam width, everything. Okay, for an end fire array. Okay, for an end fire array. Now let us solve another problem. Let us solve another problem. Now let us solve another problem. The other problem is let us solve another problem. The other problem is very important problem. So that side lobe level is minus 13.5 dB, minus 13.5 dB down from the major lobe, down from the major lobe in case of broadside array and end array. Very important problem. So that the side lobe level is minus 13.5 dB down from the major lobe in case of broadside array and end fire array. Solution. Okay. So in a so the side loop is minus 13.5 dB and the side loop is broadside array and end-fire array. Okay, so now what is the diagram say so? For example, this is the major loop direction and this is side loops. Always the magnitude of this one, is minus that this one value, this side loop levels are always less when compared to the major loop. Okay, how much times it is less? It is minus 13.5 dB down or less when compared to the major. Okay, so what is the formula for the side loop level or SLR ratio? It is the ratio of magnitude of side loop to magnitude of side loop to magnitude of major loop. Magnitude of major loop. Magnitude of major loop. Et by E naught is equal to, you know that formula, that is for an element array, Et by E naught is equal to sine n psi by 2 by sine psi by 2. Sine n psi by 2 is by sine psi by 2. So we know that the magnitude of major loop, magnitude of major loop. Okay, so we have already done the magnitude of major loop applying Et by E naught. Simply substituting psi is equal to 0. If I put psi is equal to 0, we'll get 0 by 0 indeterminate form. Okay, so then we are applying L hospital. Then we are applying L hospital. L hospital. So that is limit psi tends to 0. T by dou psi r sin n psi by 2 by dou psi r sin psi by 2. Okay. So if you substitute, we'll get the value is here. So the magnitude of major loop is here. The magnitude of major loop is here. So to get side loop, okay, to get side loop, okay, first side loop, let us take the condition is sin n psi by 2 is equal to plus or minus 1. So that is applying sin inverse on both sides. N psi by 2 is equal to plus or minus 2m plus 1 pi by 2m plus 1 pi by of the first side loop. Of the first side loop, m is equal to 1. So n psi by 2 is equal to plus or minus 2 into 1, 2 plus 3 pi by 2. 3 pi by 2. Okay. So from this, psi by 2 is equal to psi by 2 is equal to, I am bringing that 3 pi by 2n. Okay, so therefore, next magnitude of side loop, magnitude of side loop is equal to Et by E naught is equal to sin n psi by 2 by sin psi by 2 is equal to sin n into the value of psi by 2 is, what is the value of psi by 2? We have derived here. The value of psi by 2 is 3 pi by 2. Okay. So it is n into 3 pi by 2n by sin of 3 pi by 2n. Okay. N will get cancelled. Okay. So if n is very large, if n is very large, we can take it as sine 3 pi by 2n is approximately equal to 3 pi by 2. So therefore, the magnitude of side loop Et by E naught is equal to sine of 3 pi by 2 by 3 pi by 2. And the value of 3 pi by 2 is equal to 1. So it is 1 by 3 pi by 2n. So that is 2n by 3 pi. 2n by 3 pi. Okay. So therefore, magnitude of side loop, magnitude of side loop is equal to 2n by 3 pi. Therefore, what is the formula of the side loop level ratio? Magnitude of side loop by magnitude of major loop. Magnitude of major loop. What is the magnitude of side loop? 2n by 3 pi divided by what is the magnitude of major loop? It is 1. So n will get cancelled. That is 2 by 3 pi. Okay. So we are expressing side loop level ratio in dBs. So the formula is 20 log base 10 SL log is 20 log base 10 2 by 3 pi. So its value SL log in dB is equal to minus 13.4. So this is very, very important relation. So your side loop is minus 13.4 dB below when compared to the major loop.